right, we're good, right? Okay. I'm assuming anyone that wanted to scan the QR code probably already done it at this point. So we'll get started right away. So today we'll have an introduction to Kafka. We'll have a pretty high level overview of Kafka as itself. Specifically, we'll go over three things. So first, what is Kafka? A very high level overview, the motivation behind it, why would we want it in today's systems, today's architectures. Two, we'll go, how does it work? We'll go into the intricate details of how the system works in itself. And finally, we'll have a demo when we'll show like a real life application of Kafka. So first, what is Kafka? So it's a broad look. We'll look at it, and we'll also look at some use cases that people have used it in the industry today. So first, to talk about why would we need it, we first have to talk about like a shift that we've had recently. So I found this analogy online. It's pretty interesting. So think of it as before, we had like static snapshots of certain things. So for example, we would call our friends once in a while, right? Nowadays, we have continuous events. We constantly see new news about them for like feeds on Instagram. You can name all the social medias at this point, probably. Then you also have static snapshots of like news, right? You have the newspaper every day. Nowadays, you have platforms like X before Twitter or Apple News, any news platform. It's constantly coming, new feeds, new information constantly coming in. And so what this calls for is really a change. So you'll want like one platform, right, where everyone can chime in, listen in, publish events, read in events, all that in a real-time manner. Okay. And we also want a special use case or a special feature is you want these to be stored. Okay. Let's say you have events that are being distributed across the world. You want to make sure you have some sort of backup, some sort of historical archive, I guess, for these events. So with that being said, we have Kafka. Okay. And so the definition for Kafka, is open source distributed event stream platform. Now that maybe makes sense to you guys, maybe it does not. So we'll go ahead and break that down. So open source, that's pretty much self-explanatory. So it's available on the internet. It's not proprietary to any company. You can use it yourself. Distributed, we'll see. It's running on several computers, not only one. So it's not centralized. Okay. And then it's event streaming. So the idea here is you're going to be sending and receiving events. Okay. And we'll look at what events is, how we have like these records in Kafka. But where it got created was back in LinkedIn in 2010. So they had to ingest a lot of events in their website. So most notably like logs or also user interactions on their website. And there was no clear solution for how to handle all those events in real time with higher throughput. So they created Kafka. Eventually got open source, I believe, in 2011, and eventually then joined the Apache, I don't know how you call that organization, but in 2013. So some like main characteristics of Kafka. First, it's scalable and distributed. So we'll see, like I just talked about, it's running on several nodes. So it's not only running on one computer, and it also what it allows is high throughput. So we'll see that these topics where you read in events or publish events, these are split in several parts. So you're able to do like parallelization here. Then you have fault tolerance. So if a system or a node goes down, the other nodes will take up, and in real time. So everything happens very quickly. So how does this fit in? So the idea here is you have this one sort of system in the middle, right? And you have these topics where information is flowing in and out. And the idea is you can connect any system, right? These are all like, they're not connected to one another. They don't know the presence of one another. They're just connected. So they can read in data, take out data. We'll look at what those means, producer, consumers. The idea is it's one platform. And if we didn't have Kafka, we would have something where we would have like all these systems connected together, right? So let's say you have a branch from the IoT to data center, a branch from data center back to IoT for both directions, then a branch from data center to mobile. So you have this sort of web structure. So like if you know like a neural network, that's not going to be very manageable. And we'll look like an example afterwards how we go from that like web structure to a streamlined architecture with Kafka. So here it is. So without Kafka, we would have that sort of web structure, right? Everything is connected to one another. This is like a microservice, right? So you have this user initiates purchase, and it goes to a bunch of different services. And this could pretty much be a real life use case in a company, right? And so the idea here is in order to make this much simpler, you have this one sort of system in the middle here, and everything connects to it. You could subscribe to a topic, you could publish to a topic, it's all there. It's much simpler than having all these sort of connections where you have to keep up with all of them, maintain them over time. So who uses Kafka? The answer is basically everyone at this point. Now, there probably some companies that have some proprietary solution for this stuff, but a lot of companies use it. And some for use cases, for example, Netflix will use it for, I think, in their recommendation engine. They also have user interactions. That's most notably why LinkedIn created in the first place, to have those user interactions on their system. This is a bit biased, but Walmart uses it. That's where I used it this past summer, where we worked on a delivery platform, Walmart Spark. So they use that for, and we'll look at a similar use case, ride sharing. Spotify, Airbnb, they all use it. About 80% of Fortune 100 companies, which is a lot. So what are some like example use cases of Kafka, right? So for example, you might have an e-commerce website and here you want to do activity tracking. So maybe you want to track for, let's say the new trends in purchasing. Maybe you want to look at some interaction with the users and the website. So you can do all of that in Kafka, right? You'll have all those as real-time events go into your Kafka system and then you can do some analytics on top of that. Ride sharing. So this is sort of similar to what I did this past summer, where it's like a delivery platform, sort of like think of as DoorDash, Uber Eats, those sort of things. The idea here is, let's say you do like an Uber and you have this Uber you see on your phone and it's constantly updating the location of that Uber ride. They're probably using something like Kafka to update that in real time. So that is one prominent use case. I think they say that Uber is like one of the largest deployments of Kafka in the world, and they use it in a lot of their stacks. And then like bank transactions. So I know a little less about this one, but apparently a lot of some banks use this for real-time processing. Then you can add on different services on top of that for like fraud detection and stuff like that. So these are real-life use cases of Kafka that are being used today. So at its core, okay, and we'll dive into the specifics of each of these, okay, but at its core, this is what Kafka looks like on a high level, very high level. You have producers, you have consumers, you have this cluster where the information is stored, and then you have Zookeeper. So we'll go one by one. Producers just produce information in Kafka, right? These are source of information. It could be some ride sharing service, like the driver of a ride sharing service. It could be a bunch of different things, like an IoT device. We'll look at that afterwards. Consumers, they're consuming the data, right? They're reading in. You can store it in a DB. You can have some analytics service. You can have all sorts of different things going on. And then you have the cluster. We'll look at topics. They're sort of where the data is stored, like these feeds, these channels. And then we have Zookeeper. So Zookeeper, don't pay too much attention to it because all it's really using is to manage these clusters. So each of these are separate machines, okay? Zookeeper is just managing them. So they need some sort of ground truth value, ground truth, like some management service to keep up with these clusters. The reason why it's not, I say don't really pay attention to it, is because it is going away. So in 2024, there's going to be Kafka 4.0. And the idea here is they have this idea, this merge has been going on for like, I don't know how many years. And the idea is to remove Zookeeper. Okay, it's also an Apache service, but to remove Zookeeper and to make these self-controlled, self-managed. So Zookeeper at the moment is used to manage all these clusters. For example, management, like if a cluster goes down, Zookeeper is the one that takes care of that stuff, that sort of stuff. But later on, it will be removed. So that's like the general structure of Kafka. In a little more detail, Kafka is really based on 4 main APIs. Okay, so we have the producer API. So you publish records into Kafka. We already looked at that one. And then we have consumer APIs. Those you consume records from Kafka. Those are the 2 main APIs you'll use with Kafka. These next 2, okay, they're called the connector API and the streams API. Now, these are a little less popular, but they're really powerful. I haven't used them myself, but these are like the 4 main building blocks of what Kafka is. So the idea is producers, you publish records, consumer, you read those records. Now you have streams API. The idea with Streams API is that it makes it easy to do some sort of transformations in Kafka. Okay, so let's say every record that goes into, we'll go to like in detail after, but let's say every record that comes into the cluster, you want to like do some sort of filtering process. Okay, if you didn't have the Streams API, what you'd have to do is you have to have a consumer read those records, do some processing, then have a consumer producer, publish back to a topic. What the Streams API does, it like makes that process very, very easy, very simple. The connector API on itself here is it integrates external apps. So let's say you want some sort of connection to MongoDB, some connection to some other service. Well, you can have these reusable components that you just plug and play, right? And then you can connect external services as publishers or as consumers. And we'll look at different examples there too later on. So now how does it work? So we'll look at the under the hood of Kafka. So first the cluster. So we'll go in these 5 main parts we looked at before: the cluster, consumers, producers, etc. So the clusters, they're the nodes of Kafka. They're storing the information, they're facilitating the communication among producers and consumers. So it's very simple. I mean, it's just several machines you have here, and the main use case here is for fault tolerance. So you'll see that if one goes down, you have the other one that comes back up. Or you can also, we'll split topics. We'll have these we'll split topics in like 3, let's say, and we'll have them across broker 1, broker 2, broker 3. Okay. So these are just like, think of the servers that are holding the information. It's like the backbone of Kafka. So now this is where the stuff gets a bit more interesting. So how information is stored in Kafka, how information is processed, is through topics. Okay. So topics is like a feed or like a channel where all like information is of the same type is in there. So let's say you have this e-commerce platform. Yeah, maybe you have one feed for user interactions. Maybe you have one feed for like some error like log or something like that. So it's all the same type of information goes in the same topic. Okay. Now, topics in itself are again broken up in partitions. So these are like, think of it as you have this channel, and now you're breaking up your channel into several different parts. Okay, so what this allows you to do is you can have parallel processing and also scalability. Okay. So what you'd probably have is, like we saw before, we have 3 nodes, right? 3 main servers. You'd have partition 1 here, partition 2 here, partition 3 there. All the same topic though. So they're all related information. And we'll look at how these are split up, and you can explicitly do a split, or you can just let the system do it manually or automatically probably. Oh yeah, and one thing to mention is all data in partitions is ordered. So we'll look at before, because the idea is when you read in these data, you want to make sure you read it in a certain order, okay? Data in topics are not necessarily ordered, right? Because they're split up across these different partitions. Data in partitions are always ordered. We'll look at, I think, I have the next example here. Yeah. So this is what a log looks like. Yeah, go ahead. I think it's really for 2 reasons. So first, for fault tolerance reasons, right? Let's say one node goes down, okay? That means you're having everything focused on one node, and you lose everything, lose your whole system. That's why the idea of it is for it to be distributed, okay? So you have multiple nodes. If one goes down, we'll see later on how those like replication factors, so you have like these partitions all have like copies, so you can like restore from. So it's mainly for that. And second, also for performance, right? Because we'll see afterwards, you'll have consumers and producers, like they're going to read the same topic, but they might be reading partition 1, partition 2, partition 3 at the same time. So you're also going to have the performance factor. So it's really performance and fault tolerance. Yeah, yeah, pretty much, yeah. And what's interesting is when you create your topic, I think we'll look at it after in the demo. You're able to, I believe, name like how many like sort of nodes you want to create, quote unquote. Which is pretty interesting. Yeah, you can scale it like a bunch, and that's why you have systems like at Uber that have huge deployments of Kafka. Okay, so what does it look like? What does information look like in a log, in a partition log, right? So remember, topic split into multiple logs. So the first log here is these entries are in order. Okay, so through time you have more entries. This is like one record. We'll look at what a record consists of afterwards. But the idea is over time you're going to keep adding, and it's going to keep incrementing this value. It's called the offset. Okay, so you begin, the first entry has offset 0, second entry offset 1, et cetera, et cetera, et cetera. And the first entry is a start, and then you go on later on. And so we'll see how consumers are able to pull in data from this log. And then one other important concept here is you might be wondering, okay, so you're storing this information in these logs. Do you store it forever, right? Because if you store information forever, then you probably have some sort of storage issue, right? So the idea is you have several different ways you can do this. You could either put like some retention time. So let's say each entry lasts for 1 hour, or you can put, okay, I'm just going to store entries until I reach a certain memory capacity. You have different options to do it. Okay, so what is a record? So we look back, each of these, okay, is one of these records. So each record, they're also called events, right? Because event streaming platform. Each record has a few different information. Okay? So you first have headers. These are optional. You can put in metadata. You don't have to put metadata. I think we'll look at afterwards what the header looks like, or at least where you can, like, what it would look like with a header. But your main 2 parts here are a key and a value. Okay. Even the key actually is optional. You don't even need a key. The key is going to be useful when you have multiple partitions. And we'll look at how a public, basically a producer, is going to be able to direct where it wants to put those records in using that key. And then you have the value. The value is like the core of the core, right? So the value is where you have maybe like your JSON object, or maybe some like hex code, or I don't know, some byte information. That's where you're going to have the main core value of your record. And then you have the timestamp. This is just automatically done. It's whenever the thing gets published to Kafka. So you looked at before right? We have each of these topics. They're split into multiple partitions, and they're put apart like through different nodes. Okay. The idea now is you have some fault tolerance. So now you're basically going to have some replication on these partitions. So now, let's say partition 0 of topic A is going to have 2 copies on each of the different brokers. So let's say one broker goes down, you're able to retrieve that information back from the copies here. An idea we'll look at after, I think right after here, we talk about a leader and follower. Yeah. So the idea is you have several copies of the same topic, same partition. Remember, there's a lot of terms here, so you don't mix up. The same partition from a topic has multiple copies. Okay. And the idea is you have always one leader. Okay. So the producer we'll look at afterwards always publishes to the leader. The leader is like the one that has, or like the active version, let's say. Then you have followers. Again, let's say broker 1 goes down. The idea here is that you can transition the leader role back to a different partition. Now broker 2 is the leader for partition 0 of topic A. So you have this replication factor, again, built-in resiliency, which was really important. One of the main factors why LinkedIn actually created Kafka, because existing systems didn't have this sort of feature. Okay. So now we looked at how information is stored. We looked at the different clusters. Now we look at producers, how information is actually published to these systems. Yeah. So really, Kafka is, I mean, when you think of Kafka, you don't use this, you don't think of storing. Okay. The idea is you store there in case you have to retrieve back information. So that's why the idea is in this log, I mean, realistically, you could have, like, you could just say, okay, expire my entries as soon as they get read, or as soon after like 10 seconds. It doesn't really matter. But most people are going to put some sort of time, maybe like, I don't know, 72 hours, 48 hours, something like that, just so in case you can, go back and fetch them back. But ideally, you don't really think of it as a store mechanism. Okay. Sort of like a backup plan, let's say. Yeah. Yeah. I mean, and then we'll see afterwards, but I mean, you can very well have events going to Kafka and then have a connector, like a connector to MongoDB, so you write everything to MongoDB. You can have those connections where you're like, store them for the long term. But the idea is in Kafka is like a short-term storage mechanism for these entries. The real part of Kafka is, having that pipeline of events from one location to another, or multiple locations to multiple other locations. Okay. So the producers, okay, you probably already have the gist of it at this point, but they act as data centers, right? They're generating and publishing information to certain topics. It's specifically to a topic, right? So when you send, we'll look at in our demo, you always send to a specific topic. Now, you can send to a specific partition, and I think that's what this next part goes into. No, it's this slide after this. Okay, so you go to specific topics, and you always go to the leader replica. The consumer doesn't do that. So we'll look at the consumer can actually go to the followers because it doesn't really matter. But you always go to the leader, okay? And then this data sending is asynchronous, but not always. So the thing is with producers, you have multiple like sort of ACK methods, right? So you might have a completely asynchronous ACK. I think it's called ACK 0. You have ACK 0, ACK 1, I think ACK all. It is ACK 0, okay? When you send something to Kafka, you're just assuming that it's going to get registered. There's no errors that happened. The replication to the other followers worked correctly. That's fine. It's completely asynchronous. You don't need to wait for anything. You have ACK 1. ACK 1 is you send your record to a topic and you wait for that topic to say, okay, I've got it. That's ACK 1. Then you have ACK all. This is the longest one, but ACK all, you send your information to, let's say, this partition. And in this partition, let's say like the bottom 2 here, or like the 2 top ones on the right and the middle are the followers. It replicates to each follower, then it acts to you. So that's like the safest of acts, but it's not very asynchronous, so it's not very, at least, fast. And then finally, you can leverage partitioning, right? So you can have multiple producers produce to multiple partitions. Not only will it go faster there, but also in consuming. We'll see afterwards that consumers can go at different partitions at the same time, which makes the process much faster. And so some examples of what some producers might look like. So let's say we talked about ride sharing before, right? So maybe the driver of ride sharing is producing some information to Kafka, eventually being registered into some service, eventually going into like your app, and you see the driver in real time. You can have an IoT device. Maybe your IoT device has a bunch of signals, and then you want to transfer the signals across different various services. That's possible one. Well, another one is user interactions, right? So maybe you like something on Instagram, or you comment something, I don't know. All these use cases can be producers, right, in these systems. Right, so now we have multiple partitions of the same topic. Yeah, go ahead. That's a good question. And based on the demo that I actually prepared, I think that's probably the case. I don't think you most likely have a direct connection from like your mobile device, something like that, to Kafka. You always go through some sort of API, I believe, then that transfers to Kafka. Or at least that's what I used this past summer in my internship, and also what I used for this demo here. Although there may be some connectors, we'll look at connectors started as these external systems to Kafka directly. There might be connectors you can use. I don't know. I think most people go through like some sort of backend service, then to Kafka. Okay, so there's multiple partitions for a same topic, right? Which topic do you go to? Which topic does a producer produce to? So this goes back to that key, right? We mentioned that the key was technically optional, but it's very useful. They also provide some like identifying information to your record. Okay. If you don't have a key, the idea here is that it just goes in a round robin, fashion. So you produce to topic A. These are not like offset numbers. These are just like, it's like the time of insertion. Okay. So first you go to partition 1, then partition 2, then partition 3, et cetera, et cetera, et cetera. Now, if you put a key, then you usually go through this like this sort of formula to calculate which partition you go to. Usually you hash it, then you do some like modulo number of partitions. The idea here is, remember, data in a partition is order, right? Because as a consumer, you want to make sure you're reading in the same order that got produced. Let's say we'll look at afterward in a demo, but in our demo here, we have this sort of, we have like this NBA game scoreboard, right? And make sure that you're reading in data the same way it came out. Okay. So if you provide a key, what you're able to do now is everything of the same key is always going to be in the same partition. So you see here, for example, I think, yeah, the first partition has everything of key foo. The second one is everything of key lol. And the third one is everything of key wow. So now when you read in data, okay, from partition, let's say 2, you're always going to get this in order. If you didn't have this system, right, then what might happen is maybe you have, let's say you have this, okay. You're going around robin fashion. And you have consumers reading in from each of these, okay. You're not necessarily going to read these in order. Maybe this one is reading much faster for some reason than this one, and you read 1, 4, and 2, 3. That's not in order, and that might cause some issues. So most people provide a key. That way, if there is multiple partitions, you don't need multiple partitions. If there is, then you're always reading that data in order. Okay, so now we're done with producers. Now we're going to consumers. Okay, so consumers are data receivers. Okay, they subscribe to specific topics. Remember, producers publish to a specific topic. Consumers subscribe to specific topics, and they're going to be reading in information. So they always go to a specific topic, like we just said, and it's a poll-based model. So they go at their own rates, right? They don't have to match a certain rate. They don't have to tell someone what they're doing. They're completely separate from one another. So they're just reading in, they're just pulling in information at their own rate individually. And then they also completely, they maintain their current position in a topic. So we'll see afterwards, you can have multiple people read a same topic, right? That's the idea of Kafka in general, is that multiple people can read the same data. Okay? So they're going to maintain their offset in the partition. So the idea here is you have this information and you read it in, and possible examples of consumers might be like, let's say we did the ride sharing example, you'd have the app, probably go through an API before, but you probably have the app reads in, it shows the location of the user. You also have some data analytics, and maybe you're just storing directly to a database. Yeah. No, it's not asking. It's completely like, as long as there's information coming in, it's going to keep pulling. It's a pull-based model. Yeah, I mean, yeah, that is it. Like, what I'm saying is like, it's not, it comes like, think that it lives on its own. Okay, so it doesn't have to like talk to anyone to fetch that data. It just pulls at its own rate. If it's for some reason very slow and another one is very fast, then that's fine. Okay, so they completely live alone. If one like for some reason there's an error on one consumer, okay, that's its own error. It doesn't communicate with another one unless if it's in a group. We'll look at after that consumer groups. But the idea is it's purely pull based and it's purely individualized. Okay. So that's the main idea behind consumers. So now, if you have multiple consumers on a same topic, okay, like I said, they maintain each their own offset number. Maybe consumer A is at offset 2. For some reason, it's backed up, or it just got, let's say, it appeared maybe like 30 seconds after consumer B. Doesn't really matter. It's behind, but it's okay because they live on their own. So the pool-based models, they pull out their own rates. So consumer A is at offset 2. So maybe consumer A has read offset 1, offset 0, 1, 2, and consumer B is at offset 6. The idea is that they're completely individual from one another. Then you have consumer groups. So the idea of consumer groups, right, is you're able to leverage the parallelization factor here. So we mentioned that data in the same topic, so the same channel, the same type of information, is separate among different partitions on different systems, different nodes, different brokers. Okay. So now what you can do is that you can initialize a consumer group of, let's say, 2 consumers, and then there's 3 partitions. So what you'll do is each partition is assigned to a consumer. Now, no partition is never going to be left alone. Like you're not going to have, let's say, consumer 1 reading the middle partition, consumer 2 reading the right partition, and this one not being read at all. Like they're always going to be written. However, what you could have is, let's say you initialize a consumer group of 4. There's 3 partitions here. 1 consumer is going to be inactive. It's not going to do anything. But the idea here is that you can leverage that parallelization factor, and we'll look at in the demo. When we initialize a consumer, we're going to put a group ID. So technically, they're always in a group, or at least in this the library that I use in this specific language. This is another example of a consumer group what it might look like. So here we have 2 consumer groups, right? So we have multiple consumers reading the same partitions, but they're always split. So we saw here, we have 2 consumers, 3 partitions. One of them has 2. Okay. Here we have 4 consumers, 3 partitions. One of them is just inactive. Okay. And remember, they always keep their offset. So this one is keeping its offset here. This one is keeping its offset, etc. And then if you want to know a little bit more in detail how these consumers are assigned to each partition, you have a coordinator in each broker, like a coordinator for each consumer group in the brokers. That's a little bit more too much in detail for today, but that's how they're like sort of managed. You have this coordinator in each like each consumer group has one coordinator in one of the brokers. Okay, so now we looked at producers, consumers, and one thing to note is technically, if you look at it in a certain way, anything if Kafka is a producer and a consumer. From the cluster's viewpoint, anything is either publishing information or either something is reading in information. These are extra APIs, but they're technically doing that exact same thing. So the other streams API is you're able to do some sort of transformation or react to streaming data in a very simplified, in a simplicity, with simplicity. So the idea here is, I think the next slide is a good example. Yeah. So let's say you have this input topic, okay, and you have all this sort of information, and you want to do some filtering, okay? You want to, for some reason, for any record that has a key of bingo, you want to make its value capitalized, or to uppercase. Okay, this is all, and this is pretty sure it's in Java. This is all you have to write. So it's relatively simple, 4 lines. Now, if you didn't have the Streams API, what you would have is, you would have, I don't have an example here, but you have to initialize a producer, get in the data for each, get in the data, then do some sort of filter mechanism, then on top of that, build a producer, then publish the topic. So this 4 lines might become like 15, 20 lines, right? The Streams API is maybe not used as much as like some of these other APIs, but they're very valuable when you want to do some sort of transformation or aggregation or some sort of manipulation on your data. So that, yeah. That's a good question because I had no idea what this was before making this slide deck, but yes, you actually do it in an application. You don't do it in Kafka. So you have to like build a service and you build like in your, like, let's say your backend, right? You would run this as sort of like its own thing. So no, you're not like interacting with Kafka in a special way. It's actually in your service, your own services. So now you have Kafka Connect. So Kafka Connect, if you guys remember from the start, is a way to sort of connect integrations to Kafka. Again, at the end of the day, all it is producers, consumers. What it allows, though, is let's say you want to build some sort of integration between S3 and Kafka. Let's say you want to build an integration between MongoDB and Kafka. That code is always going to be the same. So what you can do now is you have these integrations, these pre-built integrations that you can just sort of plug and play in different areas. And you have two main connectors. You have sync and source connectors, which we look at just after. So the idea is source connectors, just think of them as producers. That's all they do, right? So they're just producing data into Kafka through their own system. So let's say you have a producer for one of these databases. Really, you can have a connector for a sync connector or a source connector for MongoDB. Like you can read in or read or write to MongoDB. But the idea is, let's say you have a source connector for MongoDB. The idea is you're reading information from MongoDB and you're writing to Kafka. Okay, so all it is a producer, but it's pre-built and you can just plug it and play. It's built by someone else. Maybe some of them are like, some of them you do have to pay, but a lot of them are open source. Then you have a sync connector. All the sync connector is a consumer, right? So you're reading information and then you're storing it somewhere. So examples here might be Google BigQuery. So you make some sort of analytics on the data you're fetching. Then you have Elasticsearch if you want to do, I don't know, some sort of processing in Elasticsearch. But the idea is here that you have these source and sync connectors. Everything's a source or sync connector. At the end of the day, it's just a producer and it's a consumer. As simple as that. So with that being said, I think that wraps up the slide part of this. Then we'll go into a demo. But does anyone have any questions about this before I go into the demo? I'll be honest, I'm not too familiar with other queue services. I know that now I'm not sure when those were established, but they did be on Kafka, or at least back in 2010. Let me go back to So the idea is Kafka back in 2010 at least was that these are like the main characteristics of Kafka. Okay, the reason why Kafka exists is for these right here. The idea is you had, I think it was like Rabbit MQ or something like that. These other queue services that didn't have the capability of having like super high throughput, distributed architecture, and also like real-time fault tolerant. So I can't really answer your question because I don't really know those other services. But I know that if you want to know why Kafka exists in the first place, you'd have to go back to his four major principles, right? So this is what Kafka was built on, and this is what people still use it to this day. But yeah, unfortunately, I don't really know those other queue services. Okay. So go into the demo. The demo we're going to do is I'm going to draw out an example here before I yeah. So the idea here is, can anyone see it? Can you see this? Roland, are you able to see this? Okay. The idea is our demo here is going to be we're going to simulate a real life use case, although it's not the ideal use case. But the thing is, we're going to look at the NBA. Okay. Let's just say you have a bunch of different games. Let's say each of these squares is a game. Okay. You have a bunch of different games, and they're each, let's say, we'll look at like the Lakers versus, I think, the Bucks. We'll have 4 different games going on at the same time. Okay. So you have 4 games going on. Let's just say, I have no idea if they do like this. Let's say they have some sort of system at the arena location where they keep track of like scores, fouls, turnovers, when the quarter starts, quarter ends, stuff like that. Now, let's say you have, in this case, we'll have 2 different services that are consuming. Really, they're going to be in the same service just for simplicity, but let's just say they're 2 services. You have this like website, you have this other website, and let's just say they're running on 2 completely different APIs, backends. The idea here is that if you didn't have Kafka, you go back to the web structure. You'd have to build this, you have to build this, you'd have to actually have 2-way communication, maybe just this way, and you keep going. You have this sort of web structure, and it gets very complex. The idea here is that we're going to use all right, we're just going to have this. So look back at what we did before. We're going to have this Kafka here, right? And they're all going to subscribe to this, or these are going to publish events, right? So they're going to receive like scores. Oh, someone scored. Someone is on a foul. Someone is on a turnover. And then these people would be listening in. That's all we're going to do. And we're just going to simulate that through like a script for like, we're going to generate some events in a specific NBA game. and then we'll see results on a React website. Okay, so diving into this, I have to connect. Oh. Yeah, right now you do. It is going away right now. It is 2024. Okay, should be good then. Okay, so we'll start. First we'll look at. So there is a guide. I think you got sent out in the Discord. But there's some setup. I don't expect anyone to probably follow because I think the installation of Kafka takes quite a bit of time. But if you want to do it on your own time, this goes through everything you need. There's also a Git repo with all the code for you. So you're probably going to do some setup with Kafka beforehand. Okay. But the idea here is that we're first going to look at how to set up a topic locally. So you're going to set up some sort of Kafka system locally, and then we'll connect different, like the producing and the consuming side. Okay. So to start, now this is I put it in the description here, but this is very like Mac specific, right? I'm using Brew right now to do this stuff just because it makes it like so much easier. But there's instructions if you're running on Windows or you're not running Homebrew on Mac or some sort of other operating system. So here first we start Zookeeper. So I've installed it. I've already installed it beforehand. Just going to run this. So Zookeeper again is what manages these clusters. So we always need Zookeeper for the moment. Later on, we won't need Zookeeper, but that's not right now. Then we're going to run Kafka. Okay, so these are going to run in the background. I don't want that. Okay, so now we've started both Zookeeper and Kafka. Now what we can do is we can create a topic, right? So a topic is where all information would go. Like let's say we're going to have one topic. We're not going to have a really complex example. We're going to have one topic where all NBA events, I'm going to call it NBA_events, and we're just going to put everything in there. Scores, fouls, turnovers, anything. Okay. So how you create a topic, there's probably some like UI way to do it, like some service you can run or some of that, but I'm just going to do it in the command line. So I'm going to create the topic. We're going to point to our Bootstrap server. So the Bootstrap server is like their cluster. Our cluster is at our port 9092. We're going to have a replication factor of 1. So we're not really going to have any replication. It doesn't really matter for this example, but you probably would have multiple, like a replication factor of 2 or 3. And we have only one partition. We're doing it very simple, but we're going to create our topic. Okay. So our topic is created. Now, I'll show you about, I have this script that runs that regenerates random events for like NBA games. Okay. But first, we're going to go ahead and create a producer in our command line just to show you how it works at a very basic level. So we'll go through this tutorial. If you want to download Kafka Mac Windows, this is a really good place to do so. The idea here is we're just going to create a producer. Okay. So a very similar way to how we do we create, how did that work? Yeah, so there's a thing. I use Brew. I don't think they use Brew services to start this. I think they do like I think if you look back at step 3, they do some extra step, right? They do this edit this server properties file. I didn't do that. I have no idea. Well, I think I did this back when I was doing it in my internship, but I just use Brew services. If you're using Mac, I didn't even know what it was, but it's super easy to run. You use your Brew services start and then Zookeeper or Kafka. Okay, so we're going to create a producer here. And we're going to create it. So we're going to put our same topic that we just created, right? So again, we're specifying our broker list. So this is where our cluster lives, port 9092, and we're creating this. So now we're going to be able to see, we're going to be able to enter stuff. So really what we're doing here is we're just creating entries, right? We're not putting any key, we're just putting in some value. So I'll just put some tests. Let's say test 2. We're just writing to our topic. And remember, we only have one partition. Usually probably have multiple. Okay, so we're leaving out. Now that is produced somewhere. So one way you can see your results, we'll make a consumer afterwards. But one way to do it also is through a visualization tool. So there's probably many different solutions you can use. What I use is Offset Explorer. So this is what I use, just because I used it when I used Kafka beforehand. But the idea here is you have this visualization tool for Kafka. So I'm going to make this a little bit smaller. Okay. And we're going to connect to our local cluster. Okay, now we see here we have two topics. We have this consumer offset topic. This is just keeping track of this consumer offsets. There was this MBA events topic. Okay, so what happens here, if I just click MBA events, one thing to note here is if you are using Offset Explorer, make sure, this is thinking it's very tricky and you're probably wondering why it's not working. Make sure, if you are using this, to change this byte array things to string. The reason why is because we want to view our payloads, our keys as strings. If you don't, then it's going to look very weird. So you just do this, you change it to string, then you update, then you go into data here. And here you just play this. So we see here, we have 2 entries into our topic, right? We have, again, partition 0, we only have 1 partition. Offset is, again, incrementing at each message. We have 2 values entered here, test and test 2, and they have their timestamps. We don't have a key. I don't think you can provide a key through the command line, but yeah. So we have 2 entries into our partition here, or topic more generally. And you see here, if I do the drop-down arrow here, you have multiple partitions, or at least you would have multiple partitions if you did have some. Here we just have 1 partition, so it doesn't really matter. But yeah. So now we can make a consumer and a command line, just like we did a producer. And we'll see that it's going to fetch everything from the beginning. So it's going to fetch these 2 messages. Okay. So if you run this, okay, I didn't put the right topic name. So if we go back here, we have to change this to our topic name that we just made. And then we have to okay. Okay, did that work too? Let's see. There we go. Okay, so we built a consumer and we see that we just fetched the latest message. So we did from beginning. So we just fetched the past 2 messages that we just produced. So this is like a way to create producers and consumers in command line. In your real application, you're not going to do this, right? You're just going to build them into your services. There's like libraries for all sorts of languages. You can do it. Java, I believe, is the native way. I think all the basic APIs are all in Java, but people have built over their time, things for Python. So an example here, we'll use Kafka on 2 completely different languages. We'll use it on Python to generate, and then we'll use it on Node.js to consume, so on JavaScript. So again, they're completely separate from one another. They don't know the existence of one another, but they're just producing and consuming. So now we have this topic that's created. What we can do is I have this code, which is in GitHub, if you're interested. And so we'll start by opening it up real quick. Okay, so we have 2 main folders. We have producing and consuming. Okay, so you probably want to produce first, but here we'll just set up the consuming side so that we can make sure those consumers are ready before we start producing. So here, the architecture is pretty simple. So it's sort of what you were mentioning, Jonas. That's how you say your name, right? Jonas, my bad. All right, so the idea here is that you have this. So you have these like, again, we're assuming they're separate. Really, they're living in the same React project. But we're assuming here that they have 2 completely separate APIs, right? And what you're doing is that you're connecting. Okay, these have consumers. They're reading in from here. These are producing. This is reading in. Okay, and then as a connection for these APIs to this front end, we're going to have a WebSocket. So sort of like what you guys did in the last workshop, where I have these sockets. We're also using, I think, Socket.io. So Now that that's set, we can go ahead and set up those APIs. So the first steps we're going to do is we're going to set up these APIs. We're going to run them. Then we're going to run the front end, and then we're going to run this simulation script, which just simulates these MBA events. So if we go in the back end, we have this main JS, and this is like a lot of the stuff is not really applicable to Kafka, so we'll just briefly go over it. This is just creating a server for the WebSockets, but really we're interested here at the bottom. Here we're running these consumers. So if we go in each of these consumer files, let's start with a scoreboard. This is how you initialize a consumer, or at least how you initialize it in this library for Node.js. Okay, so the idea here is that you first create this Kafka instance. Okay, you put it. You have two parameters. First, the client ID, and then you get brokers. Okay, so you mentioned before about the different brokers and how many you can put. The idea here is you probably have a list of brokers. So you just put a list of all the brokers you want. In this case, we only have one broker. Okay, because again, but we don't have multiple. We have like one cluster of one broker. You'd have multiple brokers. You'd list them there. We only have one right now. Then you create a consumer. And notes, again, like we mentioned before, you give it an explicit group ID, right? The group ID is called scoreboard group. That's because every consumer, at least here, is a part of a group. That way, they're sort of separate, right? So that means we have a different consumer after being created. It has a different group ID. They're going to read the same topic, right? But they're both going to read the same events, right? They're both going to start at offset 1, and they're going to go all the way until the end. Then you have this run scoreboard. So basically, you connect this consumer, then you subscribe to a specific topic. So remember, we created this topic a few months ago. So we're just going to listen to everything that comes into them. So it could be a foul, a score, anything. We'll look into that afterwards. And then you run, and for each message, you do a certain operation, right? So you're just fetching each of the messages, and then here we're parsing a JSON because we store them in JSON. We'll look at that, and then we handled it. This doesn't really matter. It's not Kafka specific. All it's really doing, it's doing some filtering. So the idea here is for a scoreboard. If it's a score, we're going to go ahead and send an event back to the front end. And if it's some sort of quarter or time related events, we'll do some sort of, we'll create another object. Doesn't really matter. It's not what we're really interested in. And again, we had that one, and then we also have the stats one. So again, just like we did last time, we create that consumer at the top, we provide the broker, we provide a group ID, and then for each consumer, each message we consume, we do some sort of action, right? So in this case, we're parsing JSON, and we're just sending over to the thing. And remember here, think of these two scoreboard JS and stats.js as two completely different services. Here it's not because it's for simplicity purposes, but think of it as two completely different APIs with two completely different consumers. In this case, they do have different consumers, but yeah. But in this case, we're just putting it in one project for simplicity reasons. So we're going to go ahead and run that. Okay. So now we started a server. So we're listening this WebSocket server on this port. We've created these two consumers. And then here, we create the groups, and then here we actually join the group. So now they're connected. These consumers are ready to start receiving messages in from that specific topic that we created. Now, what we'll do is we'll run the front end. Okay. So the front end is a very simple React app. If anything, we'll look at it. Run it. Okay. So let me minimize that. Okay. There we go. Okay. So we have this React app. Okay. Again, think of these. We're going to have two screens. So we'll have this scoreboard thing, the scoreboard screen, and then we'll also have a stats screen. So we're just going to copy this, and we're going to paste it here. And these are two different endpoints, but think of it really as two completely different applications. Again, for simplicity reasons, they're in the same project. But we have two different screens here. And the idea is that we're utilizing the reasoning of Kafka, right? So we have multiple services reading the same data. Okay, they're completely apart. That way we don't have to build connections for each one, right? We're just putting it in here, and whoever wants to read in just reads in through the API. Here we have consumers and consumers, and we're displaying both of these. So with that being said, I'll I'll quickly show the React app. It doesn't really matter. All we really have is for the familiar React, we have a router. We just have two different routes for those two screens we just made. And then we have these different pages where we're just receiving from the sockets. Again, if you're interested in this, you can search the GitHub. Everything is there. Now, what we can do is we can start the simulation. So, so we have this. So we looked at the consuming folder, consuming. Now this producing folder. All this is a Python script. And what this does is it has this sort of this set amount of teams. Again, this is very hard coded just for the sake of the demo. But you have these producers. Okay. So you have this class where you can initialize a producer. So what you do is that you give in you can do it however you want. I just put a class here per in order to present. But yeah, you give the bootstrap servers, you give the producer, and then you create a producer here. So the producer, again, you give the bootstrap servers, the servers you want to publish to. And then here we have two serializers. What that means is usually I think the default is like byte data. Here all we're doing is we're just making it so that we can produce keys and values of type string and type JSON. That's all we're doing. And then axall, if you remember, doesn't really matter here, but axall is you'd have axall if each time you produce to a partition, you wait until it goes to each follow replication, then it comes back as an act. Okay. Here doesn't really matter because we actually probably useless because we don't have any replications factor here. And then you send an event. So just like we subscribe to topic, we send an event, and here we provide what you'll have here. We'll look at, but basically you provide a game ID, get a game it is, and then you provide a value. So what you're doing ultimately here is just you're sending an event with a key and a value. And then you go, we initialize everything. So we initialize the bootstrap server, the port editor where it's at. Then you create producers for each game. Okay, so here we have 4 games. Remember, we're just hard coding that in, not really interesting. And then you just have, we're creating a thread for each of these games just so they run in parallel. That's all we're really doing here. We're generating events. And if you're interested, this is how we're generating events. We're just having 4 quarters. And then for each quarter, randomly, we're doing different events, like we're doing a score, a foul. So for example, here we have a score with a player and an assist, a player. You have points, 2 or 3 points, depending. You have a foul with a player and a team. We're just randomly generating these events to simulate a game. So without further ado, we have back end running. We have the front end running. Now we can just run this producing script. Okay, so right away you see it starts producing these events. And now if we go back to our front end here, you see, let me actually separate these. This is not very responsive, but that's not the point of it. The idea here is you see this is updating in real time, right? So these are reading in from the topic, right? You have these consumers, they're reading in information, and they're updating the score in real time. So we have Q1 right now that's happening. You see this, the Warriors scored 2 points, or how many they scored. And then you have also the live rankings on the right. So the idea is you have 2 completely separate applications reading in the same information, okay? And you don't have to create this sort of web structure. Everything's happening in real time. If you want here, you have the scores of each game. See, quarter 1 just ended. Eventually, quarter 2 will start. And then you also have the stats for each, like the leaderboard. So the top points player. You also have the top assist, top foul, top turnover players. And then finally, you have the leaderboard at the bottom with all their information. So again, this is nowhere near a complete application, right? So if really, you might have noticed already, but if I refresh this, right, it's going to completely mess up because it doesn't have this sort of, it's going to refresh and it's going to go back to status of begin soon because it's never going to receive that event that quarter 1 started. So this is nowhere near a complete application. What you would probably do to have a complete application is that you'd have some sort of database coming off of Kafka, right? And then you could, before going to this API to get the events, you'd go to database, get that value, come back, then start receiving events. First to get the latest updates. So that would be how you would structure this for a full application. But with that being said, that's pretty much it. This sort of demos everything happening at the same time. And if you look real quick in our topic and we play this, you'll see that we have a lot of events. In fact, if we go to the newest, we're at, it should be even newer than that, I think. Yeah. So we're at the 161 events being published at this point. And again, we don't have the I don't think they're expiring very soon. They probably have like an automatic like 24-hour expiry period. But yeah, so everything's in here, and you can look specifically at the entries of each one. If you go look in JSON here, we have this the value for each event, right? So we have the game, the heat, the team, who played or who scored, who assisted, et cetera, et cetera. Then you also have the key value here. And remember, if you guys remember, I mentioned we can have headers optional, but if we do have headers, they're going to be in here, right? So we can put the headers in here. If you have some extra metadata you want to pass in, you don't have to, but it's optional. So that is pretty much it. Does anyone have any questions on the demo? Yeah. So the idea is, okay, so right now, I mean, maybe, yeah, I'm gonna wait until Q4 starts and I'm gonna show you the issue with this. And you'll maybe it'll make you understand a little more. Once Q4 starts, well, actually, I don't even have to, I can just refresh now. Because if I refresh now, it's gonna say begin soon, and it might even like just go straight to Q4. I don't know. Um, yeah. So you see that the bottom one here, the third game here, it went directly to Q4. I refresh now. You see, it's begins soon, but it's receiving data. Okay, it's receiving. It's not accurate because what's happening is it hasn't like the quarter starts, quarter ends. Those are events that we're publishing. Okay, so what you want to do is you probably want to fetch some like the latest status of the game and then get the newest events. It's like an idea. So what you could have, possibly. Okay, remember if you go back to the slide decks, pull it up real quick, and we go to. It's gonna take a bit of time. Go to the end. We have Kafka connects. Okay, so we have these connectors, these source and sync connectors. Here we say that MongoDB is like the source connector. It's feeding in information. It could very well be a sync connector. MongoDB has both. So what you could have, okay, is you have a spinoff here, and you have this MongoDB. That's a connector. So it's everything that comes in here, maybe is going here, and then here you have some sort of streams before going into here, and it's basically making it so that whatever in here, you have the latest status of the game. So let's say you have the latest score, and then you have also the status, like what quarter it is. So one possible way you can make this into a complete, like, application that doesn't have these errors we just looked at is maybe this front end, what it's doing is it fetches the API. And again, this can be just like this also. Like you can read in and update API. It doesn't really matter how you update a DB. The idea is you might want to read this DB information first. You get the latest status. Let's say you get, okay, it's let's say the Heats and the Bucks. It's like 106 to like, I don't know, 78. And it's Q4. You fetch this information back here, then you start listening to the latest events that are coming in from here. You could structure this however you want, but that's like one possible solution of how you would get like the latest information, and that's why you'd want to have that issue that I was talking about before. It's like one way you could do it. So yeah, yeah, that would be how you do like a full application, if that makes sense. Any other questions? Okay, I think that's pretty much it. We're a little bit more past an hour, but that should be fine. Thank you for everyone that came out. I hope you learned a little bit about Kafka. Um, it's a relatively hard thing to implement in your own projects, but if you do have a utility for it, definitely use it. And a lot of companies do know like use it, so it's a great skill to have on hand. If you want to be like some sort of software engineer, you probably even use it in data science. I'm not too sure. But yeah, thank you. Yeah. Yeah. Well, I actually don't know what Redis is. I heard about it all the time. Like, what is Redis? Okay. Okay. Hmm. Yeah, 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 yeah. Okay. So one thing you could probably check is just look Kafka Redis connector, and it does seem like there is a sync connector. So what I would assume how you talked about it, it's like a cache, right? It's only storing like the latest information. So I don't know, maybe one utility, I've never used Redis. I don't know if you use like this, but maybe you have like Redis here, and like maybe, and it says here Redis is a sync connector, right? If you look Redis sync connector, right? So sync connector again is a consumer one. Okay? It's not providing information. So maybe like you're saying sync connector, maybe it's a cache and it only stores, I don't know, like the latest 10 events that just happened. And like after 10 events, it just like purges everything. So it has like the last 10 events. Last 10 events. So I guess that's one utility, how you could use Redis. But again, I've never used it, but it looks like there is a connector. So someone has built a connector for it. So I'm assuming that you can use it. So like how you were mentioning, instead of having like a database, you'd have this end memory cache. But yeah, there's a lot of plug and play utility in Kafka. You can just have all these connectors. So it's really interesting. Okay. Any other questions? All right. Thank you guys. How do I? Yeah. Well, are you running? Like, well, how did you start Zookeeper in Kafka? Yeah. Yeah. So you're using brew services right now. And I mean, one way you can check, are you sure they're running? Because one way you can check is you do brew services list and it shows everything running. Try that. Brew services list. Should I start the recording, you think, or welcome? Yeah, I'll come let me stop. There's stop or call. Stop. Oh, end the call. And meaning for